Today in Math 30-1 we're looking at topic 2.1, radical functions and transformations. Radical function. A radical function is a function, or any function, with a radical with a variable. For instance, you could look at y is equal to the square root of 3x, or y is equal to the 4 times the cubed root of 5 plus x. Each of those would be considered radical functions. Radical functions have restricted domains if the index is an even number. Let's look at some examples. If y is the square root of x, you'll notice the square root of x works for all numbers greater than 0, but doesn't work for the square root of -1, the square root of -2. So we have to restrict x to be greater than or equal to 0. How about the cubed root of x? Well, we can have the cubed root of 3, the cubed root of 8 is 2, the cubed root of 0 is 0, but the cubed root of -8 is also available, and that's -2. So for the cubed roots, there's no restrictions. How about the fourth root? Well, again, like the square root, we can have the fourth root of 16, which is 2, but the fourth root of -16 doesn't exist, nor does it exist for the fourth root of any negative number. So therefore, we can't have negatives again. So x has to be greater than or equal to 0. If we go to y to the fifth root, again is the same as the cubed root. There's going to be no restrictions because the fifth root of -32 will give me -2. So we're going to say x can be any real number, there's no restrictions. So what you're going to notice, following this same pattern, is if there's an even index on our root, or on our radical, there's got to be a restriction. However, if there's an odd index, there doesn't have to be a restriction. Let's look at example 1. Graphing radical functions using a table of values, and we're asked to state the domain and range. Well, if we looked at something simple like y is the square root of x, x is 0, so y will be the square root of 0. 1 is 1. Now we're going to jump ahead. 2, that's a messy number. 3 is a messy number. 4, the square root of 4 will be 2. Keep going. 5, 6, 7, 8. We got the square root of 9. So let's pick x as 9. The square root of 9 is 3. The next one is 16, is 4, and 25 is 5. Notice my x values, I used perfect squares. If you graph this, you will notice my x values are going to go to 25, my y values are going to go to 4. The first one is 0, 0, 1, 1, 4, 2, 9, 3, 16, 4, and 25, 5. So that's what the graph of a square root of a radical looks like. Our domain is going to be x has to be greater than or equal to 0 because it won't work, as we learned above, for negative values of x. And our range, y has to be greater than or equal to 0. Let's do another one. The square root of x minus 2. And what's happening here? Well, if x is 2, 2 minus 2 is 0, the square root will be 0. If x is 3, 3 minus 2 is 1, square root of 1 is 1. If x, the next one would be 6, because 6 minus 2 will give me the square root of 4, which is 2. 11 minus 2 is 9, square root of 9 is 3. And 18 minus 2 will give me 16, and root 16 is 4. So now I can graph this, and what's going to happen is it's going to be shifted. So the square root of x minus 2 is going to end up being exactly the same shape as our previous graph, except this time it's shifted 2 units to the right. Isn't that similar to what we learned last chapter with transformations? X has got to be greater than or equal to 2, and y still has to be greater than or equal to 0 for our domain and range. Let's do C. Y is the square root of x minus 3. So when we're picking values here, x has got to be 0. That's got to be the smallest value. 0 minus 3 is negative 3. When x is 1, we get negative 2, 4, negative 1, 9 will give us 0, and 16, square root of 16 is 4, minus 3 is 1, 25 is going to give me 5, minus 3 is 2. So let's graph this. Now my values go down from x is negative 3, and as you can see, the shape is the same, except this time now we're shifted down 3 units compared to our original graph of y is equal to the square root of x. Again, this looks very familiar to what we learned in chapter 1. So, we can use radical functions then. We can graph radical functions using transformations. Let's look at how this might work. If we took y is equal to a times b times x minus h plus k, you're looking at our, first of all, horizontal stretch of our graph by a factor of 1 over the absolute value of b. And if b was negative, that would be followed by a reflection in the y-axis. Now our second value here is a. That's going to be a vertical stretch of y equals root x by a factor of the absolute value of a. And again, if a was 0, there would also be a reflection in the x-axis. The h value is a horizontal shift, or horizontal translation. That's a shift of h. If h is greater than 0, h is going to shift to the right. And if h is less than 0, h will shift to the left. But because it's minus, it's going to show up as a minus. So don't be confused here. If this said x minus 7, h would be 7. H would be greater than 0, and it would be shifted to the right. Lastly, our vertical translation of k units, up if positive, down if negative. Let's look at example 2. Let's graph radical functions using these transformations. So here's an example. We have y is equal to 3 times the value of the square root of the negative of x minus 1. This tells me my b value is going to be negative 1. That's the number in front that's been factored out. A is going to be 3, and h is going to be 1. And that's what I was saying about minus h. So if we plotted these points and compared it to our original graph of y is equal to root x, we're first of all going to draw our original graph of y equals root x. And now we're going to go through the steps to transform this. Now the first thing that the book does is does the vertical stretch. So instead of doing the horizontal stretch, we're going to do the vertical stretch. And that's 3 times the square root of x. So all my y values are going to be times by 3, and that's what it's going to look like. Now my b value is negative 1. So that means that the horizontal stretch is going to be 1, which means it doesn't change. But now there's going to be a reflection in the y-axis. So that means all of my x values are going to be negative. Therefore, it's going to look like that. There's my reflection in the y-axis. Lastly, h is 1. So now what I'm going to have is there's going to be a shift of 1 unit to the right. that's what it's going to look like when everything is all said and done. My final graph is the graph in red. Your assignment for this section is to do page 72, numbers 1 to 8.